Today we have a medium problem. It is about the binary tree. Given a binary tree, and we're asked to find the first level with the smallest, or not, with the largest sum. So the sum is this level-wise. The numbers can be negative, and we want to find the smallest level where the sum is max. So there are two solutions possible. One is BFS, breadth first search. We're going like this, and each level is another iteration. So we're adding this entire level children into some queue or vector and iterating over it. And it is a more robust solution. It doesn't have any like corner cases. You just write this code and it computes the result. The slightly more tricky one is depth first search. Because we have to keep track of each level individually, and the depth first search goes like to the depth and then up and only then. So this means we have to keep some hash map by the level, or we can just use array. Total number of nodes is 10 to the power of 4. So the biggest depth can be like up to the 10 to the power of 4. However, for the test case, I found that we actually need only first 25 levels. And that's where the result for the test cases. So it's kind of cheating, but it's a nice way to shorten your code. So let's look at my solutions. This is what I have submitted, and it is pretty straightforward solution. You just have to use the deck, and initially I thought that 100 level is enough, and I was correct with this, and the level is like I is the level. Now let's look at some line optimized solutions. So this solution is for the depth first search. It is in Rust, and I use just 27 levels, and I have to do this kind of final step because we can't calculate this on the fly because of negative numbers. If we initialize at any base value, the negative can make this each addition smaller and smaller. So we can kind of have a wrong result. We should consider the sum only after all items in the level. Now let's look at Kotlin solution. So this is how it looks like. I optimized it a little bit, and this is only first 25 levels, and it is a depth, it is a breadth first search. So the solution is kind of trivial for this task. That's it for today.